Hello everyone, I'm your JS professor. So this is my first video and today we will be learning scope in JavaScript. You must be wondering that there are so many videos and online content about scope in JavaScript, then why should you watch this video? So let me give a brief introduction about myself. I am a software engineer working in front end with JavaScript from last 10 years and I take a lot of interviews of beginners as well as experienced professionals. So what I have noticed that people answer in an interview what is hoisting, what is this in JavaScript, and what is closures, but they are confused about how it is working behind the scenes because they do know the definition of it, but the moment you give them the question where they have to apply it, they get confused about it. So today our aim is that we learn how the scope in JavaScript works, and the concept is called lexical environment. So that is what we will be covering in this video. So let's get started. So here I have created a function. I have named it as create stopwatch, and then there is a local variable inside a function named as tick. I have initialized its value as 0. Then this function is returning another function, which we call it a nested function. And the nested function itself is returning a tick value with a post increment operator. After that, I have declared a variable named as ticker, which is storing whatever is returned from calling the function called create stopwatch. And after that, I am console logging it three invocations of ticker. So if I ask you a question like all these three tickers will be independent or will be sharing a value. So let's run it and find it out. So as we can see on the right hand side that these tickers are not independent. They are sharing a value. First call is showing you the value 0, second value is showing value 1, and third is showing you the value 2. But if I ask you that what is the reason of this sharing? Most of you will answer it very easily, like that this is because of the concept of closures. And then I ask, what is a closure? Then you'll be answering, closure is basically a function that can access its outer variables. That's it. But today we will go behind the scenes and decipher what a closure actually mean and how it works. Okay. So first of all, what is a scope in JavaScript? In JavaScript, the whole script has one scope. Every function in JavaScript has its own internal scope. And at last, every code block has its own scope. And what a code block means? A if block, maybe a for loop, a while loop, or even a normal brace is also a code block. Like for example, if I put two braces and I write let name equals to JS this is also a code block. So this name is the part has its scope within this two braces itself. Okay. Now what is a lexical environment? So lexical environment, we can define it as it is a internal and a hidden object associated with either a script or a function or any code block. So you can see every scope in JavaScript has its lexical environment associated with it. Okay, lexical environment. So what we have learned, it is an internal, or you can say a hidden object. Now, this internal or hidden object consists of two parts. The first part is called environment record. So, and the second part is a pointer. Okay. So what is environment record? It is also an object which stores all the variables as its properties for that particular scope. Okay. And what does this pointer do? Pointer refers to outer lexical environment. We will get to this. What is a outer lexical environment? So we can say, since we know that the script as a whole has one scope, so you can say the scope associated with the whole script, you can call it as a global lexical environment, right? So for a script, you can say it has a global lexical environment, and this global lexical environment's pointer will be pointing to null. Why null? Because it does not have anything to point to outside of it. Okay. So to understand the lexical environment, we will divide it into four parts. First of all, we'll understand how lexical environment work for variables. If I say let language, or let's have a short variable name called lang, and I said JavaScript JS. So what happens at the start of the script itself? It knows about its variables. Okay, so let me depict everything pictorially for you guys. So for example, at the start of the script itself, let's say this box donates a lexical environment, the global one, and it knows about a variable called lang, and it is in uninitialized state. Okay, and we have a we can say we have a pointer which will be pointing to null. Okay, so when the script starts, lexical environment pre-populates all the declared variables in its scope into an uninitialized state. This state is an internal state, so you cannot actually reference refer this variable till it is declared using the keyword lang. Okay, so let's take an example. Suppose there is a variable, okay, and you try to access it before it. Let's try to console log it. So what do you think what will happen? Let's see. See, reference error, right? And why it is happening? Because you are trying to access the variable before it is declared. But many of you must be thinking, this is a simple concept of hoisting. What's new in that? We already knew it. Whenever we declare, we always, know the definitions over the internet. Whenever we declare a variable using a let or const keyword, then these are not hoisted. And when we use a keyword where, then they are hoisted. But what does actually hoisting means? So essentially, we can say that changing the value of a variable is essentially changing the properties of this environment record object, which is the part of lexical environment. So if I say let lang a variable having a value JS, okay, or let me make it more interesting. Let's say I just declare a variable, then I assign it a value JS, then I assign it a value TS. So let's see how its lexical environment will look like. So at the start of the script, in the lexical environment, there would be a variable named lang, which would be an uninitialized state. So you can, that is why you have read about that if you try to create a variable using a keyword let or const, then initially that are in a dead zone, or we call it a temporal dead zone. So what is a temporal dead zone? That at the start of the script, lexical environment knows about the variable, but it is internal and hidden. You cannot reference it through your code. That is why you get a reference error. Okay. Now, the moment you hit the line in the code where you use the keyword let, then I'll show you how the lexical environment looks like. It will be lang and undefined. Did you get it? So what happened? That everything remains same. Now all, do not get confused with undefined and uninitialized. Undefined is a legal value in JavaScript, whereas uninitialized is equivalent to that the variable does not exist for you to access it. It has a value undefined. Then the moment we assign a value to it called JS, then now I know pretty much sure that you'll know what we will be doing. So what will happen? Now this undefined value will change to TS, sorry, first JS, then to TS. Okay. Now let's move ahead to the second part of lexical environment. We have understood that how lexical environment works for variables. And the good part is, unknowingly, we have also understood how hosting works under behind the scenes. Now you don't have to remember that whether let or const would be hosted and where would not be hosted. And whenever you get any kind of question related to hosting, you just apply this concept and you'll get the right output. We will do some questions at the end of the video. So just be there. So now let's start with function declaration. Second point is how lexical environment works with function declaration. So first part was variables. Now everybody will be knowing that function declarations are also hosted. And in case of function declarations, we are able to use the function even before its definition, right? So this is because in lexical environment, function declaration are instantly fully initialized. That is, you can use it even before declaration. Okay. So for example, so I have a function named getLang. Okay. Even if I put the call of the function before it, even then it gets called. But we will understand why. Okay. Why it happens. So at the start of script, what will happen now? Now this will have two things. One, it will say I have getLang function. And it won't be in uninitialized state like variable. It will be having the whole function itself. And second thing, it will be having a lang variable which is in uninitialized state. That is why we always say function declarations are hoisted. Now, do not get confused with this kind of syntax. Suppose I create a variable called maybe function and I store the call of this function into this. So these are called function expressions and these are not hoisted. So similarly, it it is not the part of lexical environment. Okay. So let's go deeper into the functions. Into our third part of lexical environment, we will understand inner and outer lexical environments. Okay. So basic rule is simple. There is an inner lexical environment, and if we do not find a variable in inner lexical environment, we try to find into the outer lexical environment and so on. That is a simple rule. And if we do not find that variable in the whole chain of lexical environment till the global lexical environment, then if you are using use strict mode, you must be nowadays everybody is using use strict mode. So in usual scenario, if you are using use strict mode, then that would be an error. Otherwise, in old scripts, that variable will be created as a property of global object, as a property of global object, as a property of global object with the value undefined. Okay. So let's again understand it pictorially. So let's take this example where I have a function getLang. I'm calling it with a value hi. It has a parameter called greet. It is using its own parameter. Then it is having a, a variable outside of it, outside the scope of function called lang, which has the value js, and it is combining the two values of it. We all know it will be showing the value hi lang. Okay, but the question arises how the JavaScript engine understands it. So what happens the moment the function call starts? So at 38th line I'm there. The moment function call starts, how the lexical environment looks like. Let me show you. It will be having, so what we have in the function scope, only one variable. So we will apply our previous logic which we understood in terms of variables. We will say there is a greet variable whose value is high. So this is just to tell you, this lexical environment is created on function call. So this got created on function call. It was not there earlier. This lexical environment got created dynamically. Now it will be having a pointer. Now pointer will be what pointer will be having? It will be pointing to the outer lexical environment. So for this get lang function, what is the outer lexical environment? It is the global one, the lexical environment associated with the script itself. Okay, so let's draw it as well. So let's call, so this is our outer lexical environment. And how the outer lexical environment would be looking like? It will be saying, I have only a lang variable whose value is JS. And again, that would be pointing to null, right? Okay. So how this function call works? When you call the function getLang with the value high, it immediately for this function a lexical environment got created and it says I have a variable greet whose value is high. The moment 36th line is hit, we are trying to console log by concatenating two variables. Now it searches for the lang variable in its own lexical environment. It sees that I do not have a lang variable. So it says go to the outer lexical environment to find the variable. And it sees yes, lang JS is the variable is there whose value is JS. So it is able to print hi JS. So we can say what we can conclude. It searches for variable in lexical environment chain. Search for variable. Okay. So that is the precise reason if I, before the function call, if I change the value of lang variable to ts, so it will now print greet like hi ts. Why? Because you have changed the value of the variable when the lexical environment get created on the function call, it knows that now the lang variable will be having its latest value ts, which we just created above. The whole diagram we created above, that first what will happen, the script gets started, lang will be uninitialized, then it will be undefined, then the moment the let keyword is hit, you have assigned the value, then it would be js, and then it would be ts. Okay, and just for to verify our conclusion, we will run it as well. So if we see hi ts, it is printing that, right? Okay, now we'll be going to our next part, which we call it returning a function. Returning a function. Now let's get back to our original problem statement, which was how this ticker is working, right? So let's start with so global. अगर हम सबसे पहले ग्लोबल लेक्सिकल एनवायरनमेंट को डिफाइन कर लेते हैं. लेट्स डिफाइन द global lexical environment. We will say it will be having a variable ticker with a value function. Which function it would be? It would be, in fact, I should say it would be undefined because it will get the value only once it is called. Okay. Now let's go to line number 12. So this is our global, and what else global has? It has a variable ticker and it also has a, so function declarations are hoisted. What happens with that? With that definition, you will be having a function create stop watch, okay, and it will be saying it is a function, right? So our global lexical environment looks like this, where at the start of the script itself, it has, it knows about a function declaration, and it says it's a, I have a function named as create stopwatch, which is a function, and I also know about a variable named as ticker. Okay, initially it will be in uninitialized state. The moment 10th line hits, okay, it will also be having a function which will be this internal function. Okay, but we will get back to it. So right now we can say it is in uninitialized state. Okay, now what happens? The moment 10th line is hit, that is the call to the function create stopwatch. तो क्या होगा? So we have learned that during a function call, a lexical environment is created on the fly. So let's create one. There is a lexical environment of this function call. Okay, what will happen? It will say I have a tick which whose value is 0. I have this variable tick whose value is 0, right? And what it will say? It will be pointing to the outer lexical environment which we already discussed. Now, what about this internal nested function? We have created on the function call at 10th line, we have created a lexical environment. We say there is a variable with tick with value 0. It is pointing to a outer lexical environment which we already know. What about this internal nested function? So the funda is that all function remember their lexical environment in which they are made. So ये जो anonymous function है कि we have not given any name, it knows its lexical environment in which it was created. But how? That is the question. So every function. So let's even go deep. So let's go to the line number 12. What happens when you call ticker? Right? You will be actually giving call to a nested function which you received, right? So so on a function call, we create a lexical environment, then it will be pointing to its outer lexical environment. But if you see this function, the scope of this function does not have any variables of its own. It says, I want to return a tick variable and Then I want to increment its value. So it searches its own. Let's, for sake of completeness, let's write it's a empty lexical environment. Okay. So what happens that it says that that I want to return a variable tick and I want to increment its value afterwards after returning it. So it searches for its own lexical environment, did not find the variable tick. It goes to the outer lexical environment. It is able to find the value tick. Okay, and it returns it. So the value of ticket 0, it returns it. You are able to see it on your console. And after that, it changes the value to 1. When the second call comes, it follows the same process. That is why you were able to see the output as 0, 1, and 2. A shared, this is a shared ticker. These are not independent calls. Now the question arises that I am outside this function, create stopwatch. Okay. And we know that closure means that it is able to access the outer variables, right? And for this nested function, tick is the outer variable, right? But the question arises how how it maintains, how this la- this connection is maintained, because हमने तो ये फंक्शन बाद में कॉल किया है, तो इस फंक्शन को इसका आउटर लेक्सिकल एनवायरनमेंट के बारे में कैसे पता था? क्योंकि लेक्सिकल एनवायरनमेंट गेट क्रिएटेड व्हेन फंक्शन इज कॉल्ड. सो इसका आउटर लेक्सिकल, इस नेस्टेड फंक्शन का आउटर लेक्सिकल एनवायरनमेंट में टिक पड़ा है और उसकी पूरी लेक्सिकल एनवायरनमेंट की चेन है उसके बारे में, इसको कैसे कैसे ये इसको कहाँ स्टोर करेगा? सो एवरी फंक्शन हैज अ हिडन प्रॉपर्टी. Okay, what's that hidden property? So you can say, so since your this nested function is stored in the variable ticker, we call this, let's say this is a ticker function itself. Ticker function dot, there is a property called environment. Okay, what this environment property does, it stores the pointer to the outer lexical environment, and this property is there with every function. So stopwatch की जो property होगी function की, उसके अंदर global lexical environment पड़ा होगा. Okay, and similarly जो anonymous ये function है, हमारा nested function, इसकी environment property में इसका outer lexical environment पड़ा होगा. इसका outer lexical environment is the scope of create stopwatch function, right? So that is, here we conclude that this is how closures, hoisting, and even some to some extent the concept of this and inheritance works with the concept of lexical environment. That is why you don't have to remember anything, that what how things get hosted if you know the concept of lexical environment. And similarly, you don't have to mug up the concept of closures. Now you know what does that is why we say all functions are closures in JavaScript by default, right? That is why we are able to pass around the function in JavaScript and calls from anywhere in the code, and still the function remembers its lexical environment, right? So we can conclude that all lexical environments, all functions remember their lexical environments in which they were made. or you can no matter where, no matter where they get called. So, and one you can also conclude one more thing, the this environment reference, this environment reference, this reference is set forever at the function creation time. So function creation time के at that time जब आपने उसको सेट कर दिया वो forever के लिए सेट हो गया. It does not change over time. That is how JavaScript works. Now there is a small note to the whole concept, that is garbage collection. So how does these lexical environments which gets created in memory get cleared? So the moment there is no pointer referring to a lexical environment, the JavaScript will definitely remove it. Garbage collector automatically remove it. So the moment you nested function की कॉल खत्म हो जाएगी तो ऑटोमेटिकली उसका एनवायरनमेंट डिलीट हो जाएगा मेमोरी से. सिमिलरली सेम गोज फॉर क्रिएट स्टॉप फंक्शन का एनवायरनमेंट. स्क्रिप्ट का लेक्सिकल एनवायरनमेंट हमेशा रहेगा जब तक स्क्रिप्ट चल रही है. जैसे स्क्रिप्ट खत्म हो जाएगी तो उसका भी डिस्ट्रॉय हो जाएगा. राइट नाउ आई show you an interesting problem. So तो अगर आपको एक्सप्लिसिटली लेक्सिकल एनवायरनमेंट कलेक्ट कराना है तो यू कैन जस्ट मार्क टिकर वेरिएबल एज नल. जैसे ही टिकर वेरिएबल नल होगा तो क्या होगा, अब इस एम्प्टी वाले लेक्सिकल एनवायरनमेंट को कोई भी पॉइंट नहीं कर रहा है. ठीक है, तो ऑटोमेटिकली इट इज एलिजिबल फॉर गार्बेज कलेक्शन. दिस वन मोर थिंग आई वांट टू टेल यू. सो एंड there's one more adage also. सो अगर मैं 3 कॉल्स करता हूँ क्रिएट स्टॉप वॉच के तो 3 लेक्सिकल एनवायरनमेंट्स क्रिएट हो जाएंगे मेमोरी में, अलग अलग, बिल्कुल सेपरेट. ओके गाइस, सो लेट्स कमेंट ऑल ऑफ दिस. सबसे पहले क्वेश्चन करते हैं आवर सेकंड क्वेश्चन. सो व्हाट विल बी द आउटपुट ऑफ दिस क्वेश्चन. हमने एक वेरिएबल लिया, उसका नाम जावास्क्रिप्ट रखा, लैंग्वेज उस वेरिएबल का नाम है, हमने गेट लैंग्वेज करा एंड गेट लैंग्वेज कॉल होने से पहले उसका हमने वैल्यू चेंज कर दिया टू टाइपस्क्रिप्ट. सो एज यू मोस्ट ऑफ यू गेस्ड इज राइट, वैल्यू आएगी आंसर में. यहाँ पे हम कंट्रोल F5 करेंगे. टाइपस्क्रिप्ट. वाई? क्योंकि सेम कॉन्सेप्ट, द मोमेंट गेट लैंग्वेज कॉल हुआ उसका एक लेक्सिकल एनवायरनमेंट क्रिएट हुआ. जब वो लेक्सिकल एनवायरनमेंट क्रिएट हुआ तो उसने जैसे ही प्रिंट करने गया लैंग्वेज, उसने अपने आउटर लेक्सिकल एनवायरनमेंट को कहा मुझे लैंग्वेज की वैल्यू चाहिए. तब तक उस आउटर लेक्सिकल एनवायरनमेंट में वैल्यू चेंज हो चुकी है. ठीक है, सो लेट्स गो बैक, लेट्स डू अनदर क्वेश्चन. अब क्या है कि हमने एक एक अंदर वेरिएबल है लैंग्वेज, गेट लैंग्वेज के अंदर, जिसका टाइम जावास्क्रिप्ट है, और एक बाहर है टाइपस्क्रिप्ट. फिर हमने एक फंक्शन गेट लैंग्वेज को कॉल करा दिया. कॉल कराने के बाद उसको एक वेरिएबल में स्टोर करा, फिर उस वेरिएबल को कॉल कराया, तो उस वेरिएबल में स्टोर हुआ उसका नेस्टेड फंक्शन, और बेसिकली उस नेस्टेड फंक्शन को कॉल गई. ठीक है, तो सबसे पहले हम 60th लाइन से शुरू करेंगे. जैसे ही गेट लैंग्वेज फंक्शन कॉल होगा तो उसका एक लेक्सिकल एनवायरनमेंट क्रिएट हो जाएगा. वो क्या करेगा, वो एक वेरिएबल क्रिएट करेगा लैंग्वेज, उसकी वैल्यू डालेगा जावास्क्रिप्ट, और वो अपने एनवायरनमेंट प्रॉपर्टी में, सॉरी नॉट दिस, फिर उसके बाद ये फंक्शन अपने क्रिएशन टाइम पे ही, नेस्टेड फंक्शन अपने एनवायरनमेंट प्रॉपर्टी में इस पूरे स्कोप को, इस पूरे लेक्सिकल एनवायरनमेंट को अपने एनवायरनमेंट प्रॉपर्टी में डाल देगा। नाउ जब लैंग वेरिएबल कॉल होगा विच हैज द नेस्टेड फंक्शन, तो क्या होगा, जब 55th लाइन पे वो आएगा, उसका जो लेक्सिकल एनवायरनमेंट है वो एम्प्टी है, वो आउटर में देखेगा, उसको लैंग्वेज मिल जाएगा, तो उसको जावास्क्रिप्ट टाइप करना चाहिए, बिकॉज उसको इसके भी आउटर लेक्सिकल एनवायरनमेंट में सेम वेरिएबल पड़ा है लैंग्वेज जिसका टाइप स्क्रिप्ट है, बट वो सबसे जल्दी जो वैल्यू दे देगा while coming from deep to till the global lexical environment. So the answer should be JavaScript. Let's check. See, answer is JavaScript, not TypeScript. Okay, let's go back. And now this is an interesting question. अब हमने एक वही जो ऊपर स्टॉप वॉच यूज कर रहे थे, सेम सेम है। अब हमने दो काउंटर्स दो बार कॉलिंग करी। अब हमें ये वाला तो ऊपर वाला क्वेश्चन तो पता है, ये शेयर्ड होता है टिकर की वैल्यूज को जब हम कॉल करते रहते हैं, क्यों क्यों होता है, वी हैव ऑलरेडी अंडरस्टूड। जीरो और वन वैल्यू प्रिंट होती है। जब मैं काउंटर टू जो वेरिएबल है उसको यूज करूंगा, क्या काउंटर टू की वैल्यू शेयर्ड होगी, क्या वो टू और थ्री प्रिंट करेगा, या वो बिल्कुल इंडिपेंडेंट होगी? सो लेट्स चेक। So we are able to see 0101 which means counter 2 is independent of ticker. Why? क्योंकि जब जो हमने ऊपर भी यहाँ समझा था कि अगर आप तीन बार कॉल कर दोगे तो आपके उतने लेक्सिकल एनवायरनमेंट्स क्रिएट हो जाएंगे, इस वजह से ये दोनों काउंटर्स आर इंडिपेंडेंट ऑफ ईच अदर। लेट्स गो टू नेक्स्ट क्वेश्चन। सो ये बेसिकली कंस्ट्रक्टर फंक्शन है जावास्क्रिप्ट का, और आपको ये समझ में आएगा कि क्लासेस कैसे वर्क करती है जावास्क्रिप्ट में। सो हमने एक कंस्ट्रक्टर फंक्शन को न्यू वेरिएबल से टिकर आ गया इसमें, बेसिकली न्यू यूज करते हैं तो उसका दिस रिटर्न होके सेव हो जाता है इस वेरिएबल, एंड उसके फिर हमने फंक्शंस कॉल करे इंक्रीमेंट इंक्रीमेंट देन डिक्रीमेंट, और वो क्या कर रहा है, अब क्या होगा, अब सबसे पहले क्या होगा, हम इंक्रीमेंट की कॉल पे जाएंगे, ये अपना लेक्सिकल एनवायरनमेंट क्रिएट करेगा जो एम्प्टी होगा, वो कहेगा मेरे को टिक वेरिएबल को पहले इंक्रीमेंट करना है फिर रिटर्न करना है, बट उसका टिक वेरिएबल होगा नहीं, वो अपने आउटर लेक्सिकल एनवायरनमेंट में जाएगा, क्योंकि उसने क्रिएशन टाइम पे ही अपने एनवायरनमेंट प्रॉपर्टी में इस इस आउटर लेक्सिकल एनवायरनमेंट को स्टोर करके रखा होगा, उसमें वो उस वैल्यू को ले आएगा, तो वो वैल्यू वन रिटर्न कर देगा पहले, फिर दूसरी बारी में उसको टू कर देगा, क्योंकि ये दोनों सेम आउटर लेक्सिकल एनवायरनमेंट में कर रहे हैं, तो जब वो माइनस करेगा तो सेम ही टिक अफेक्ट होगा, तो आंसर शुड बी ओके, वन टू वन। तो सबसे पहले वन आया, टू आया, फिर डिक्रीमेंट होके वन हो गया। नाउ लेट्स गो टू अनदर एग्जांपल। सो वैल्यू, एक हमने वैल्यू ली है, इसकी वैल्यू वन है, फिर हमने एक फंक्शन बनाया है जो उस वैल्यू को एक्सेस करने की कोशिश कर रहा है, और फिर वैल्यू एक और उसके अंदर सेम नाम का एक और वेरिएबल है val2। तो क्या होगा, हम अपना लेक्सिकल एनवायरनमेंट के अप्रोच फॉलो करेंगे, फंक्शन कॉलिंग गई, इसका लेक्सिकल एनवायरनमेंट क्रिएट हुआ, इसने क्या कर, जैसे ही लेक्सिकल एनवायरनमेंट क्रिएट होता है वो क्या करता है, अपने स्कोप से रिलेटेड सारे वेरिएबल्स को अनइनिशियलाइज स्टेट में रख लेता है, उसको तो वैल वेरिएबल के बारे में पता है, लेकिन जब तक लेट कीवर्ड हिट नहीं होगा तब तक वो अनडिफाइंड वैल्यू भी उसको नहीं देगा, यहाँ जैसे कि अभी यहाँ तो साइन ही डायरेक्टली हो रहा है, तो अभी नहीं होगा, तो जैसे ही आप कंसोल लॉग करने की कोशिश करोगे तो आएगा एरर, बिकॉज आप उसको वो अभी अनइनिशियलाइज स्टेट में, विच आई अर्लियर टोल्ड यू इट इज इक्वलेंट टू दैट द variable does not exist for the JavaScript engine. Okay, let's go back. Now this is an interesting problem. So suppose करो बहुत सारे आर्चर्स है, एक मैंने फंक्शन बनाया क्रिएट आर्चर्स, वो क्या कर रहा है, एक एरे बनाया उसने, वाइल लूप यूज़ किया 10 तक, और एक इंटरनल नेस्टेड फंक्शन बनाया, उसको एक वेरिएबल में स्टोर किया, वो नेस्टेड फंक्शन उस आई वैल्यू वाली वेरिएबल को कंसोल लॉग कर रहा है, मैंने उस नेस्टेड फंक्शन को एरे में पुश कर दिया, आई प्लस प्लस कर दिया, ऐसे मैंने 10 बार करा, और पूरा का पूरा एरे मैंने रिटर्न कर दिया। तो जब मैंने क्रिएट आर्चर्स करा, क्रिएट आर्चर्स आर्चर्स में आ गया, ठीक है, और जब मैंने फिर क्या किया, हर एक इंडेक्स में जो, अभी तीन मान लेते, तीन बार मैंने उसको कॉलिंग करी। फर्स्ट इंडेक्स जीरो था, फर्स्ट इंडेक्स पे जो जो भी नेस्टेड फंक्शन पड़े थे, तो क्या होगा वे, लेट्स सी क्या आउटपुट आ रहा है। ठीक है, आउटपुट आ रहा है 10 10 10। मैं तो एक्सपेक्ट कर रहा था कि यार ये 0 1 2 आना चाहिए था, क्योंकि मैंने तो जब इसको स्टोर किया आई की वैल्यू जीरो थी, राइट। तो ये ऐसा क्यों हो रहा है? तो सिंपल कॉन्सेप्ट, जब क्रिएट आर्चर्स कॉल हुआ, इसने अपना लेक्सिकल एनवायरनमेंट बनाया, इसने एक एरे बनाया। तो लेक्सिकल एनवायरनमेंट में क्या होगा, एक आर्चर्स नाम का वेरिएबल जिस जो एक एम्प्टी एरे है। उसके बाद क्या होगा, एक आई नाम का वेरिएबल जिसकी वैल्यू जीरो है। फिर लूप चला। ठीक है, लूप में क्या हुआ, एक और आर्चर नाम का वेरिएबल जिसकी वैल्यू फंक्शन है। ठीक है, दैट्स इट। उसके बाद आपने पुश कर दिया, बट जब एक्चुअल कॉलिंग गई आर्चर्स को, इसका एनवायरनमेंट तो तब क्रिएट हुआ। तो जब एनवायरनमेंट क्रिएट हुआ और जब इसने आई देखा, मेरे पास मेरा तो लेक्सिकल एनवायरनमेंट एम्प्टी है, तो ये आउटर लेक्सिकल एनवायरनमेंट में गया। आउटर लेक्सिकल एनवायरनमेंट में क्योंकि लूप पूरा चल चुका है 140th लाइन पे, तो वैल्यू आई की 10 है, उसने तो उसी समय एक्सेस करी जब उसने कॉल करा, ड्यू टू विच ऑल द कॉल्स आर शोइंग यू 10। अगर हमें इसको फिक्स करना है तो सिंपल हमें एक काम करना चाहिए था, इसके स्कोप में एक नया वेरिएबल क्रिएट कर दो, लेट जे, जिसकी वैल्यू आई हो, और हम इसको कह देते हैं कि आप जे प्रिंट कराओ। ठीक है, अब क्या होगा, लेट्स सी, 0 1 2। अब ऐसा कैसे करेक्शन आ गया, क्योंकि अब इसको अपने आउटर लेक्सिकल एनवायरनमेंट के बारे में पता है, तो इसको उस मोमेंट के बारे में पता है कि जब जे की वैल्यू क्या थी। तो जे की वैल्यू वो थी उस लूप में चलने के। और इसका एक और बेटर सोल्यूशन है, दैट इज वाई पीपल प्रेफर कि हमेशा कोड में मैक्सिमम टाइम पे फॉर लूप यूज करो, क्योंकि फॉर लूप बाय डिफॉल्ट हर समय लेक्सिकल एनवायरनमेंट हर एक आइटरेशन के लिए कॉल करता है। ये देखो, अगर मैं फॉर लूप यूज करता तो मुझे कोई ज़रूरत नहीं थी जे यूज करने की, और इनफैक्ट इस आई वेरिएबल की भी ज़रूरत नहीं है। अब मैं इसको कॉल करूंगा तो भी आपका फंक्शन, फिर भी आपका रिजल्ट सेम आ जाएगा, 0 1 2। So that's all from my side, guys. I hope you like the video, and please give me the feedback in the comments कि how what are the things I should improve in my teaching style, and whatever you want to have an improvement in terms of the video. And please do comment what are the other concepts you would like me to cover. Thank you.